Hello, my name is James Campbell, and I'll be discussing James Webb and use of spectroscopy. First of all, what is the James Webb Telescope? It is NASA's largest and most powerful space telescope. It cost over $10 billion in a decade to make, and it launched recently on December 25th, 2021. It currently orbits the Earth at the L2 Lagrange point, where the Earth is always in between the Sun and the space telescope so as not to interfere with the Sun's light, not to damage the space telescope's delicate instruments. James Webb's core mission is to view the earliest light possible, as close to the Big Bang as it can get, potentially view the forming of galaxies, view the formation of planets and stars, and look at planets for hints of life using spectroscopy. Now, what is spectroscopy? As we discussed in Chapter 2, it's the study of how electromagnetic radiation, both visible and invisible light to the human eye, and matter interact. It is one of the few ways to get an understanding of deep space objects, as we only really have light to go off of all of our discoveries. James Webb uses the absorption spectrum to see the makeup of planets using infrared light. Uh, it does this as spectroscopy is more useful on planets orbiting edgewise facing us than from overhead, as when the planets eclipse the sun, James Webb can use the difference between the light of the sun and the light coming through the atmosphere to get an estimation of what that atmosphere is made up of. Using that, it has made two discoveries over this past summer. First of all, in July, it discovered that a planet over 1,100 light years away has H2O in its atmosphere, potentially water vapor, potentially clouds. This is a Jupiter-like planet with the mass of Saturn orbiting its sun at a distance one-ninth the distance Mercury does. So it only takes 3.5 days to orbit around its sun. So we get a ton of data points about this planet. More miraculously is that for the first time, James Webb has discovered CO2 outside of our solar system and a solar system 700 light years away. This is also a gaseous planet like Jupiter with the mass of Saturn that orbits its sun in about 4 days. So we can also get a ton of data points on this. As you can see in this little image here, it has a transit light curve, which is the starlight of the sun normally, and then the starlight when this planet passes it, eclipses it. So we can see based off how much light is absorbed, what matter is more likely to be there. And in this case, it's CO2. These discoveries play a big part in understanding how solar systems and planets form, as well as how unique our own solar system truly is, as before this, CO2 has only been discovered in our own solar system. James Webb can see in much more detail than any other previous telescope, leading to a greater understanding of our universe and the potential to find life on rocky planets.